Hi, my name's Eric. Partnered with Profit AI this year, working on an AI-powered bird health detection system. Um, so the problem that Profit AI is trying to solve is monitoring animal health at scale. It's really difficult because a lot of these farms house like thousands of birds in one place, and the pens are extremely crowded, meaning that you can't really manually monitor these chickens. So subtle signs of illness, like where they are in the pen, if they're drinking more or eating more food, or their movement or their waddle change. Um, that doesn't isn't noticed until it's potentially too late. So the consequences are reduced animal welfare. There's risks of infection when there are dead birds in these cages, and huge wasted feed and uh, loss of increased costs for farmers, which also affects us, not only our wallets, but the environment as a whole. So one early warning signal how a bird walks is its waddle. And that's one of the metrics that I focused on during this internship. So um, Profit AI has, they use sorry, computer vision models to track birds through time and space. And so with these trajectories, we can look at decomposing those into movement and time spent in space. So one of the things I worked on is decomposing that motion into a forward and lateral motion, and applying like windows in time to quantify whether a bird is moving, whether it's waddling, also applying like high pass filters to isolate the rhythmic oscillation of a waddle versus where like if it's just bending and moving in space, as well as computing features like I just described the lateral to forward ratio, which is how much is moving side to side versus forward and back, um, spectral power and heading change, which is which direction is it going in, and also what's the frequency of motion. If you can detect there's a lot of noise and movement, obviously, if you're walking. So if you can figure out whether it's waddle or whether it's just random movement. Um, yeah, so my key findings were I was working on this feature engineering pipeline and intent system that transforms this trajectory data into behavioral metrics. And some of the most statistically significant features I found were the lateral to forward motion ratio, which again is how much is the bird moving forward versus side to side, which took a lot of work to first make sure the data was clean so that could be analyzed, meaning getting rid of windows that the bird wasn't moving or um, kind of correcting, figuring out whether it's waddle or just random movement, as well as lateral root mean squared. So how much is it uh, moving kind of side to side? Um, so impact and next steps. This is extremely important because, again, better animal welfare and lower losses in mortality rates means uh, better sustainability practices. Chickens are also just cheaper for the general populace. And this is really big if it's scalable. So in these facilities, Profit is installed these cameras that kind of look down on the chickens. So there's no need for manual oversight at all, which leads to more sustainable, responsible food systems in general. So the next steps for Profit AI is going to be refining those weights based off of waddle and some of the other metrics, train a classifier to figure out whether a chicken is healthy, in danger, or unhealthy, and integrate that into a dashboard for farmers. I really enjoyed the project. It was really cool building an AI-powered system and tools. And I'd just like to thank again BU Urban and Profit AI for having me. Thanks.